Liquid nitrogen is widely used in research facilities around the world. Liquid nitrogen can freeze biological tissues for storage or cool a system or chemical reaction. Always remember, there are real and significant hazards associated with the use and storage of liquid nitrogen. In this video, we will discuss the hazards associated with liquid nitrogen, parts of a liquid nitrogen tank, including the safety features, safely dispensing liquid nitrogen and handling cryogenic tubes, filling a liquid nitrogen tank at a dispensing facility, and what to do in an emergency, safely transporting liquid nitrogen within a building, other cryogenic liquids requiring additional safety considerations. There are three primary health and safety hazards associated with liquid nitrogen. Extreme cold. Liquid nitrogen can cause instant severe frostbite to skin or eyes. A jet of vapors can freeze tissue faster than liquid or metal contact. Proper use of personal protective equipment can help prevent exposure. This includes a lab coat, safety glasses or chemical splash goggles and a full face shield, protective gloves specifically designed for use with cryogens, sturdy shoes that cover your feet, pants without cuffs that could trap liquid next to your body.
Always remember to wear PPE when removing or handling cryotubes and cryotubes that may be filled with infectious material.
Extreme cold can also change the nature of materials. It can make some rubber or plastic materials more brittle and allow them to break easily. To prevent breakage, use only materials designed for use with liquid nitrogen cylinders and attach only transfer hoses designed for liquid nitrogen. Asphyxiation. Large spills of liquid nitrogen can immediately displace oxygen, especially in poorly ventilated areas like cold rooms. Since nitrogen is odorless and invisible, fill and store nitrogen containers in well-ventilated areas. Contact your safety office to determine if a space where liquid nitrogen will be used or stored is well ventilated or may require oxygen depletion alarms. Expansion. Liquid nitrogen can expand up to 700 times when changing from liquid to gas. Rapid changes in temperature can result in rapid or explosive conversion to gas. Rupture incidents have occurred in university laboratories after users had inadvertently altered or obstructed safety relief devices, or tanks became dented and compromised. Pipes, vessels, NMR tubes, and cryotubes with trapped liquid can violently rupture, causing injury and exposure. Avoid storing liquid nitrogen tanks near heat sources with direct exposure to the sun or in locations where the temperature can fluctuate widely. Consult the tank manufacturer's operating manual and get familiar with the functioning of the tank valves and piping circuits. A typical liquid nitrogen tank has multiple pressure relief valves. Never obstruct, block, cover, or tape a pressure relief valve.
If your cylinder vents loudly through the relief valve, is cold to the touch, or has frost buildup around the pressure relief valve, leave the room and contact emergency services.
Know your liquid nitrogen tank. Liquid nitrogen tanks are typically 1.5 meters tall, 50 centimeters in diameter, and contain 100 to 160 liters of liquid. Tanks consist of an inner and outer vessel. The vacuum space between the two vessels acts as a highly efficient thermal barrier. Special materials inside the vessel maintain the vacuum for several years. These portable liquid nitrogen tanks are specifically designed so the liquid nitrogen is safely insulated to ensure users are well protected from the extreme cold during handling or transport, and the user can withdraw the contents either as liquid or as gas.
If the cylinder is dented or damaged during transport or use, the tank must be professionally inspected to ensure it may continue to be used safely.
Cylinders are equipped with pressure relief valves that will open and close to release gas at preset pressures. The primary pressure relief valve opens at the lowest pressure and regularly vents excess gas. A slight hiss from a liquid nitrogen tank indicates normal operation of the primary pressure relief valve. A small gauge installed on the cylinder may show the pressure inside the tank. This gauge reading should be equal to or less than the setting of the primary pressure relief valve. The secondary pressure relief valve is set at a higher pressure. On this tank, this valve is installed on an extended stainless tube to ensure its opening if the primary relief valve is blocked by ice buildup or fails in any way. If both relief valves fail or are not able to handle the pressure, a burst disc at the bottom of the tank may blow out and vent the pressure to prevent a tank rupture. The primary and secondary pressure relief valves on this tank are set at approximately 20 psi and 50 psi. Other liquid nitrogen tanks may be rated for higher pressure settings, so be aware of the specifications for your tank. Do not remove or tamper with any of these safety devices or their protective covers. If your research group owns a liquid nitrogen tank, it is your responsibility to maintain the tank in good operating condition.
If there are unexpected leaks from your cylinder, valves or O-rings may require maintenance. For assistance, contact the university staff member responsible for the liquid nitrogen facility.
Dispensing liquid nitrogen. Liquid nitrogen tanks should always be stored and operated in areas with plenty of ventilation. Liquid nitrogen tanks must always be stored and operated in the upright position.
Operators should never block, plug, or attempt to repair anything on a liquid nitrogen tank containing liquid. For assistance, contact the university staff member responsible for the liquid nitrogen facility.
Always wear appropriate personal protective equipment before withdrawing liquid nitrogen liquid from a tank or withdrawing cryotubes. Depending on tank style, there may be 4 different piping circuits on a liquid nitrogen tank: the liquid dispensing circuit, the pressure building circuit, the economizer circuit, and the gas use circuit. Consult the tank manufacturer's operating manual and get familiar with the functioning of the regulators, valves, and piping circuits. For dispensing, connect a manufacturer-approved transfer line for liquid nitrogen. The natural evaporation rate alone is often not capable of providing enough pressure. The tank pressure can be boosted by the pressure builder circuit with which most nitrogen tanks are equipped. Pressure builder styles may vary. The pressure builder regulator and pressure builder valve adjust when liquid nitrogen is introduced to the pressure building circuit. Liquid nitrogen in the pressure building circuit is turned to gas and delivered back into the top vapor space of the tank. This increases the pressure inside the tank, allowing the liquid from the bottom of the tank to be delivered to the liquid valve. Keep in mind that opening the pressure builder circuit will not immediately increase the pressure inside the tank. The pressure building process may take several minutes. Become familiar with the different cylinder pressure builders you may work with. Once a pressure builder regulator is set, it should not be changed. Transfer of liquid at high pressures can lead to excessive splashing. Boiling and splashing always occur when filling a warm dewar or when inserting objects into the liquid. Perform these operations slowly to minimize the splashing and boiling.
Never trap liquid nitrogen between 2 valves, inside lines, or inside containers without a properly installed and rated pressure relief device.
Pressure relief settings and tank styles for other cryogens like carbon dioxide, argon, helium, oxygen, or hydrogen may vary. Cryotubes, or vessels stored under liquid nitrogen, may rupture without warning when removed from a liquid nitrogen dewar. One reason this occurs may be that liquid nitrogen has seeped inside the cryovial or along the threads of the cap. Another reason is that liquid nitrogen-cooled vessels or traps condense and liquefy oxygen from the air. Never reach into liquid nitrogen. Always use a mechanical device to retrieve items. Filling the liquid nitrogen tank. The typical evaporation rate for an unused liquid nitrogen tank is between 2 to 3% per day. In a month, the tank will lose 40 to 60% of its contents due to natural evaporation. The level gauges on tanks are mostly float-type, liquid-level sensors that roughly indicate the level of liquid nitrogen. Gauge styles may vary.
When refilling your tank at a fill station, follow all posted procedures.
Step 1. Weigh-in. To fill the tank, begin first by weighing your empty tank on the scale. Record the empty weight, your name, the current date, and the account to which the service should be billed.
Before attaching your tank to a fill station, don the proper personal protective equipment.
Step 2. Attach the tank. Place the liquid nitrogen tank directly in front of one of the fill stations. Step 3. Open the loop. First, open the vent valve of your liquid nitrogen tank by turning the valve handle counterclockwise. Then open the fill valve in a similar way. Step 4. Start the flow. First, flip the on-off switch to on, then depress the fill button. The green indicator light is lit during the fill process. Step 5. Monitor the flow. Normally, your liquid nitrogen tank will take approximately 30 minutes to fill. If the filling stations haven't been used recently, it may take as long as 1 hour. Liquid nitrogen from the bulk system will flow down the inside dip tube of the tank and fill it. Excess gas exits through the vent line. The physical principle is that liquid will always flow from a vessel of higher pressure to a vessel of lower pressure. Before removing your tank from a fill station, don the proper personal protective equipment. Step 6. Stop the flow. When the filling process is complete, flip the on-off switch to off. Step 7. Close the loop. Close the liquid valve, then the vent valve on your tank. Step 8. Remove the tank. Warm up the pipe connections with the heat gun.
Never stand in front of the fill or vent ports of the station or the tank.
Step 9. Detach the tank. With the provided wrench, gently remove the connections to the fill station. Step 10. Weigh out. Weigh the full tank and record the weight. Responding to emergencies inside the liquid nitrogen facility. If the liquid nitrogen supply system does not shut off, or there is a break in the liquid nitrogen distribution system, take action. Exit the room, locate the emergency shutoff button outside the facility, and push the button. Call emergency services. A bulk liquid nitrogen facility must be equipped with an oxygen depletion alarm.
If you hear this alarm or see the red flashing lights indicating an unsafe condition, exit immediately. Call emergency services.
When moving tanks on campus, 2 people should transport tanks up or down ramps, over cracks, door jams, or uneven pavement. When transporting a tank in an elevator, it is allowable to accompany a single liquid nitrogen tank in an elevator cab. But the best practice is to have a person on each floor sending the unaccompanied tank. Use only designated freight elevators for tanks. This training program only covers aspects of manual transport of the liquid nitrogen tanks on campus.
Contact your safety office before transporting liquid nitrogen tanks off campus. Safe options are available for shipping frozen materials.
Additional safety concerns. Use of liquid nitrogen is common inside of labs. Since it is an inert gas, it can be safely used in open, well-ventilated spaces. If you intend to work with other cryogens like argon, helium, oxygen, or hydrogen, contact your safety program for assistance. The information provided in this video is for demonstration purposes only and is not intended as a substitute for proper health and safety training. Lab conditions shown here do not reflect the conditions which may be present in a particular lab. You should consult with qualified health and safety professionals, including those at your research or educational institution, regarding any question you may have about proper lab safety practices.